So in today's lesson, we're just going to kind of compare what we know about linear versus exponential to compare and figure out in real world examples which one is the better choice. So just remind yourself that linear is when we look at things that are going to be straight lines. And also linears have constant rates of change. And when we write linear equations, we write them in the form y equals mx plus b, all right, where m, that's my slope or my rate of change, and b is my starting value. Now when we look at exponential graphs, we have seen so far, they grow, if we're talking about growth, they grow very quickly. And these are going to have percent rates of change. You should probably make a note with the graph that these grow quickly. And in this case, we have our equations that look like y equals our starting value times 1 plus or minus a percentage to the x power. That's the same format that we've been using this entire week to write out our word problems. So let's look at one or two problems just so we have the basis to work from when we get to class tomorrow. All right, so in this example, we're not actually going to answer the question yet because it says to use a graphing calculator, so we're going to wait and do that tomorrow. But what we need to do to be able to use our calculator is write equations. So take a second to write down everything that it says right here about jobs A and job B. Okay, so job A, the first thing we need to do is figure out, is what they've given us a linear or an exponential function? And job A, it doesn't have anything to do with a percent, but it does give me a rate of $100 every month. All right, so we've got a rate here, and it's a constant rate because it's just a value, not a percent. So because it's a constant rate, job A is going to be linear. And that means I want to write this as y equals mx plus b. So I'm going to say y equals my rate, which is 100, x plus my starting value, which is 1,000. Okay? Now job B, if I want to write that one out, they still give me a starting value of 1,000, but this time my rate every is a percentage. So because I have a percentage as my rate, that means this time I'm going to have an exponential. So when I go to write my equation this time, it's going to be y equals 1,000, and then in parentheses, it's a raise every month, so we're increasing, so that means we're going to do 1 plus, and remember to write our percentages out, we always have to move the decimal. So that means this is going to end up being 0.01. So in my equation, 0.01. And then exponential, you still have to have a variable somewhere in your equation, so your variable is going to be your exponent. All right, like we did yesterday, if you'll leave some space in your notes, we'll come back to this example tomorrow. All right, here's another one for us to write just so you feel a little bit better. So when you read job A, all right, they give me a starting value, a rate of 200 every month. Since that's a constant rate, that is going to be linear. So again, I'm going to write y equals mx plus b. So for job A, I've got y equals 200 as my rate, 200x, plus my starting value of 1,000. For job B, they give me a starting value of 1,000, and this time it's a percentage raise every month, which means I'm going to be writing exponential. So this time I'm going to say y equals 1,000. It's a raise, so we're going up, so that's 1 plus. Remember, we got to change our percentage to a decimal. So it's going to be 0.04, and then x as the exponent. And we'll use these, just like with the last example, we'll use these to answer some things using our calculator tomorrow.